at the end of any typical calculus text, you're going to find what we refer to as tables of integration. Formulas that allow you to just not use any of your integration techniques and simply evaluate an integral like that one. Now, of course, the one I just put up here is expressed in terms of another integral, but it's just reducing the order for the secant of x in the integrand's position. You just reapply it until you get something as simple as sine or secant squared or secant to the first. Now, I don't care if I don't state this in the instructions. For any quiz or any exam remaining this semester, I never want you to use any of these tables of integration. I don't care to see you actually use formulas. I know we can all do it at this level. But I think this is a good question. Given that this is a standard formula you find in any table of integration, can you prove it? So here I go. With what I've said so far in this chapter, doesn't it seem reasonable that in the integrand's position, I merely want to shave off 2 factors of the secant of x? Because now with partial fraction decomposition, I misspoke. I meant to say, and now with my integration by parts formula, since I can differentiate this one easily, anti-differentiate this one easily, it appears that integration by parts might work. Let's give it a shot. Now, my integration by parts formula tells me that with this integral involving a u dv, I can re-express it as a product of my u and my v minus the integral involved my v du. So look at my v, it's right here, and my du is doubly underlined here. Looks to me like I have a coefficient n-2 out front. But in the integrand's position, don't I have n-2 factors of secant, 2 factors of tangent? And if you allow me to massage this a tad bit. Now, distributing this multiplication with less subtraction. Uh-oh. Did I write that twice? My goodness. What came over me? Now take a peek at how this term and this term involve the same integral, the one I started with. So if I add n-2 of these integrals to both sides, it's going to give me an n-1 of them on the left-hand side. And let's see what's left over on the right-hand side. Now, at this stage, oh shoot, are we done? Do you mind if I don't finish? Now, if you merely divide both sides by that coefficient, that's exactly what you get.